So this is a demonstration problem in biostatistics where we're going to use the one sample z-test for proportions. Now stick around to the end because not only do I do this problem with pen and paper, but I also show you how to do it using ChatGPT. Leave me a comment down below how you feel about using generative AI to help you either generate problems or to check up on your work to help you study biostatistics. Leave me that comment. So let's have a look at the problem. The proportion of the population of people who have had peripheral vascular disease surgery, so that's our population we're looking at, everyone who's had surgery for narrowing of the arteries in their limbs, these are usually the lower limbs, due to chronic arterial insufficiency. They have narrowing of these arteries, maybe it's because of cholesterol and smoking. Anyway, who believe that continued smoking puts them at risk for amputation. And that's thought to be 60%. So in this population, they've had surgery to clear up these arteries because of narrowing, and they smoke. And so they were just, the question was put to them, do you think continuing smoking puts you at risk for an amputation? And 60% of them say yes. So that is the proportion of these people under the null hypothesis. Now, researchers collect data from 100 random subjects in the population and record that 55 out of these 100 believe that continued smoking puts them at risk for amputation. So there's your survey, they fill in the survey, and only 55 out of those 100. So the question is, the researchers want to test the claim that the population proportion of people who have peripheral vascular disease surgery due to chronic arterial insufficiency, who believe that continued smoking puts them at risk for amputation, is not 60%, using a 5% level of significance. And we instructed in this problem to use a z-test for proportions to test the claim. We can use the z-test. This is a binary categorical variable. They say either yes or no when this question is put to them. So generate a solution to this problem using the following 7 steps. And those, remember, are our steps that we use. State the population parameters, state the null hypothesis, state the level of significance, state the test statistic to be used and the important assumptions for the test, and state the test statistic and its distribution under the null hypothesis. Remember, and then we calculate that test statistic. Step number 6 for us, always make a decision based on the critical value. We're not going to do the p-value here, just the critical value approach. And then we write a test conclusion. So remember, I always like my step number 0. We just want to summarize this data. So can we summarize what has been given to us in this problem? So let's put step number 0. And we're just going to summarize. So under the null hypothesis, we're going to put that is said to be 0.6% of these people say yes. And then we take 100 people, so let's say n equals 100, and we want to know, out of those, what is our estimate? Well, that is going to be 0.55 because 55 out of 100. So let's put it here, the frequency was of those that said yes. I'm just going to put it there so I do remember it's 55. And then our alpha value, we were instructed to test this at a 5% level of significance. So let's do step number 1. And step number 1, remember, what are the parameters that we are after? So we really want p sub 0, that is the proportion of people. So let me write this out. All right, so I said p, that's supposed to be a colon there because I don't want to put p sub 0. That is the proportion of people, and the population that we're describing is those who've had surgery for peripheral vascular disease that believe that continued smoking puts them at risk for amputation. So they had one of the major risk factors for peripheral vascular disease, which is smoking. They've had surgery either by some kind of bypass or a stent, usually bypass surgery, and now they're told to stop smoking because there's a risk that the condition continues and it ends up in an amputation. And so 60, under the null hypothesis, that would be 60%, and we need to find that out. So let's see, step number 2 is we're going to state the null and alternative hypothesis. So our null hypothesis here is that p sub 0 equals 0.6, and our alternative hypothesis, very simple, that this value under the null hypothesis is not equal to 0.6. So let's go to step number 3. We're going to just state the level of significance, and we'll simply write alpha equals 0.05 for step. Now we're going to do step number 4. So step number 4, we really want to know the statistical test that we can use and the most important assumptions for this test. And so we're going to say that we use a one or single sample z-test for proportions. So why can we state that? Why do we want that? Yes, we have a single sample here for a single variable. They, just this one question was put to them and they said yes, no, yes, no, yes, no. We're going to assume that these are all independent and that we have identical distributions. So for every single individual, the probability that they said yes was 60%. And now we just have to know, do we have a large enough sample size here so that what we find here can be modeled by the z distribution? And what we really want to look at, let me put it in green because I think it's important for us just to jot it down. We're going to say the following. What we need is n. Let's get a green pen. I like to put my my equations in green. So I'm going to say n times p sub 0. And I'm going to have that n times 1 minus p sub 0. So actually our successes and our failure. And we want these to be at least 5, and we want that to be at least 5. And if we do this calculation, we have n equals 100. So we have 100 times 0.6, and that gives us 60. And 100 times 1 minus 0.6 is 0.4, and that gives us 40. And indeed, 60 and 40, they're both at least 5. So we can use the z distribution as a model if we use the right equation to model what we find from the data. So let's do that in step number 5. So step number, that's the wrong pen, isn't it? I'm sure you're all shouting, wrong pen, wrong pen. So step number 5, we're going to calculate the z statistic. So this is going to be a z statistic. It is described by the normal distribution, and that's the standard normal distribution, I should say, on a mean of 0 and standard deviation or variance of 1, and that should happen under the null hypothesis. How do we calculate this? Let's go to the green again. So we're going to say that z equals p hat minus p sub 0 divided by some standard error. And of course, the standard error for this difference, and if you look at the numerator, what are we trying to say? What's the difference between what we find and what we expect per unit of standard error? So how do we calculate the standard error? Well, it's p sub 0, 1 minus p sub 0, divided by n. So let's just say that, of course, it's the square root, but inside of the square root is divided by n. Great, let's put in the values that we have for this problem. So that for us is going to be z equals p hat that we found, 55 out of 100, that would be 0.55, minus the proportion of those who said yes under the null hypothesis is 0.6, and we want to divide that by the square root of, now we have to take this p sub 0, the proportion under the null hypothesis. That's going to be 0.6, 1 minus 0.6. You can think of it as proportion of successes times proportion of failures. You want to do that divided by our sample size, and we had a sample size of 100. So let's put this in. That's the division. There is our... Oh, you have to wait for this thing to dry on this rodeo paper. It really just doesn't dry. And so if you do that on a calculator, let's see, I get negative 1.02. I get about negative 1.02. So we are negative 1 standard errors away from 0. So step number 6, of course, we need a critical value, and we need to see, how is this in the region of rejection for a 5% level of significance, two-tailed. Let's have a look at that. So step number 6 is our decision rule. And so we need a critical value, z critical value, and we need that for, remember, for 5% level of significance. And when it comes to the standard normal distribution, I think we all know that this critical value, and now I'm talking on the positive side, that's going to be 1.96. So remember, this is a symmetrical distribution. This is a two-tailed alternative hypothesis. Remember, we just said under the alternative hypothesis, it's not 0.6. It's going to be more, can be less. And so I have to think about the negative 1.96 and the positive 1.96. So let's look at our value. our value was negative 0.12. So what you can do with these, all we're going to do is take our z value, we take the absolute value of that, and we compare that to the positive version of our critical value. And we want that to be larger for us to reject. But in this instance, we have negative 0.12 positive, or the absolute value of that positive 1.02. That is not larger than our critical value. So in our instance, that would be 1.02 is not larger than 1.96. So we failed to reject the null hypothesis. Great. And so in step number 7, we just need to write a test conclusion. And I'll write it here. And there you go. There's not enough evidence in the data at the 5% level of significance to show that the proportion of people who have had surgery for peripheral vascular disease who believe that continued smoking puts them at risk for an amputation is not 60%. So I'm very clear about describing this population, describing what this problem is, and we failed to reject that, so we don't have enough evidence to say that it's not 60%, so we are stuck with a 60%. So as promised, let's have a look at what ChatGPT has to say about this problem. So I'm using the web interface here of ChatGPT, and I'm choosing the GPT-03 Mini High model here. That's a bit of overkill. And of course, by the time you watch this video, we might be at ChatGPT 47. Who knows? Anyway, now it's a bit smaller on the screen. Let's increase that size. Perhaps you could see a little bit better. And I said, help me with the following biostatistics example problem. The proportion of the population of people who've had peripheral vascular disease due to chronic arterial insufficiency who believe that continued smoking puts them at risk for amputation is thought to be 0.6. Now, you can see me there, once again, as always, I do put the dollar symbols around any kind of mathematical notation, so that's called LaTeX or LaTeX notation for mathematical typesetting. And I do find that ChatGPT, specifically these OpenAI models, are very good at reading LaTeX as a compared to the models from other companies. And when I want to put in a complicated equation, there's no words to describe, not an easy way to describe an equation just in normal English. You can, but of course it's much easier just to write the mathematical typesetting. And as always, if you want to see just a video on mathematical typesetting using LaTeX, just a general introduction to that, because it's just so nice to know mathematical typesetting, do put a comment down below. And if I have time, I can think about it. Anyway, researchers collect data from 100. Again, 100, I want that to be a number. I put it in dollars, surrounded by dollar symbols, indicating this is LaTeX. Anyway, 100 random subjects record that 55 believe that this puts them at risk for amputation. The researchers want to test the claim that the population proportion of people, blah, 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 is not 60% using a 5% level of significance. And then we were instructed to use a z-test. And again, look at my z there. It's inside dollar symbols. As I say, I think ChatGPT handles that particularly well. If you want to, as I say, put in an equation there, it works really well, the mathematical typesetting. In any way, generate a solution to this problem using the following 7 steps. So this was me basically copy and pasting the problem. And I've prepended that by saying, help me with the following biostatistics example problem. And then I'm adding to the end, generate a solution to this problem using the following 7 steps. And there are the 7 steps. I write them all out. And then the reasoning happened for about 6 seconds. And then below is a step-by-step solution using the z-test for proportion. So let's have a look. It said that the population parameter of interest is the true proportion P of people who've had peripheral vascular disease or surgery due to chronic arterial insufficiency and who believe that continued smoking puts them at risk for amputation. So see how nicely well written out that was. In the correct version there, you should not actually put P sub 0 because that's the value under the null hypothesis. That's not what we're interested in. We are interested in this true proportion, this true population proportion. The null and alternative hypothesis, the null hypothesis that this proportion is 0.6, the alternative hypothesis that it's not 0.6. And see the correct version there as well. You should actually not put P sub 0 there. That's not what the hypotheses are. The hypothesis is that the true proportion is 60% or the true proportion is not 60%. So I think this is a very good demonstration of the correct way to write your null and alternative hypothesis. So that's a good point there. And then saying this is a two-tailed test. So some added information there, which I think is very good. The level of significance, alpha equals 0.05. That's fantastic. Test and the assumptions. And we use a z-test for proportions. The sample is randomly selected. The sample size is large enough for sampling distribution of the proportion to be approximately normal. and look n times p sub 0, just as we did, the 60 and the 40, and that's at least both greater or equal to greater than 5. That's fine. And then finally, these observations, as I mentioned, they are independent. We're just going to assume that. Now, the test statistic for proportion is z. There we have p hat minus p sub 0 divided by its standard error, as you can see there. And then we have there p hat is 0.55, p sub 0 is 0.6, n equals 100. What I would like to see there, that it states there z equals this under the null hypothesis, but that's fine. I think we can all assume that to be so. It calculates the standard error, that's the denominator, remember, and it also gets the solution negative 1.02, so that's fantastic. Decision rule based on the critical value. For two-tailed test at alpha equals 0.5, the critical z values are approximately plus or minus 1.96. You can use your software for that. You can use a spreadsheet software and to calculate these values. But for the z distribution, I think it's just nice to just memorize these plus or minus 1.96. Of course, the calculated z value does not fall beyond negative 1.96 or positive 1.96. So we failed to reject the null hypothesis. And then the test conclusion, at the 5% level of significance, there's insufficient evidence to reject the claim that the population proportion of people who believe that continued smoking puts them at risk for amputation is 60%. Thus, the data do not show significant difference from the stated proportion of 0.6. A different way of stating it, but I think that's good. And that was it. So very easy to use ChatGPT to generate the solutions here for you. Of course, as someone who is learning to do this, you really do trust that you do this yourself first and then use ChatGPT to verify your work. Can ChatGPT make a mistake? Yes, it says so right at the bottom. Always remember that. And I think it would be low probability that both you and ChatGPT make the same mistake, but that is certainly possible. I think the probability is very low. So I'm quite happy for you to use ChatGPT or another model to verify your work. Now, I went ahead, that wasn't part of the problem, but I also said, thank you. Please calculate the 95%. Look, I've put 95 again in dollar symbols, percent. Confidence interval for the population proportion of people with peripheral vascular disease, believe, etc., etc., etc. And it gives me this nice equation. It's going to say p hat, this proportion, our sample proportion, plus or minus. Now, instead of c, it puts z alpha over 2. That's our confidence coefficient, times the standard error. But remember here, the standard error does not contain p sub 0. This time it's p hat, 1 minus p hat over n. So a different way here to calculate the standard error than we did when we just used z. So please do take note of that. Plugs in all the values for us and gets a lower limit of 0.4525 and an upper limit of 64.75. So that's our confidence interval. We are 95% confident that the true population proportion of people who say yes for this question is between 45% and 64.75%. Remember, that's what we state, but that's not quite correct. The correct interpretation of a confidence interval saying if we do the study many times over, every time we'll get slightly different confidence intervals due to variability in our selection of our observations of these subjects from which we get the observations, that in 95% of those cases will contain the true population proportion and 5% of them will not. Our one single study, we never know if it's one of the 95% or one of the 5%. But of course, 95% much bigger than 5%. So the interval means that we are 95% confident. See here, it states what we usually say and what we read in journal articles, which is not quite the truth as I've just explained, but we all do it, so that's quite acceptable. The interval means that we are 95% confident that the true proportion of people with peripheral vascular disease believe that continued smoking puts them at risk. So it actually should include a little bit about surgery there. I saw it did it in the beginning as well, so it's not completely describing the population that we had in the problem. But anyway, it's between 45.3 and 64.8%. And of course, the value under the null hypothesis, which was 60%, is contained within this. And so another way for us to see that we failed to reject the null hypothesis.